Hello class, this is a video tutorial on local maxima and minima, part 3. In this video we'll be looking how to determine whether a stationary point is a maxima or a minima using the second derivative. So to determine whether a stationary point is a local maxima or minima, first we need to find our stationary points, and then some points, P, A, F of A is a local maxima if the second derivative of that value A is less than 0, meaning it's concave down, and some point Q, B, F of B is a local minima if the second derivative of that point is greater than 0. Now the reason for this is if this point is concave down and it's stationary, then it must be a maxima, because points to be concave down like this have maximum points, and points such as this, if they are concave up, have minimum points, such as that one. So let's get straight into some examples. Find the coordinates of any stationary points and determine their nature. So for this, we're going to need the first derivative and the second derivative. So let's derive these. So this is going to become x squared minus 4x minus 5. Let's factor this straight away. So give me x plus 1, x minus 5. Okay, and that's going to be for later. And now let's find the second derivative. And we do this just by differentiating against the first derivative. So this one will become 2x minus 4. Okay. Now that we have all the points that we need, let's find any stationary points. Stationary points. For this, we're gonna solve this for 0. So x plus 1, x minus 5 is equal to 0. Well, this is x equals negative 1, x equals positive 5. So now let's find the nature of these points. Nature, meaning that we're going to test f double prime of negative 1. Well, this is going to be 2 times negative 1 minus 4. Well, this is going to be negative 2 minus 4, which is negative 6. So f double prime of negative 1 is less than 0. Less than 0 of the second derivative means it's concave down, meaning that this point here is a maximum. So we can say x equals negative 1 is a maxima. Actually, I really should move this below our test here. Let's move this across. And let's just get rid of this, because why not? Let's find now the second derivative. F double prime of 5 is equal to, substituting to this point here, is going to be 2 times 5 minus 4. That's 10 minus 4, which is 6. And that's positive, so we can say f double prime of 6 is greater than 0. Greater than 0 means it's concave up. That's concave up, meaning that's a local minima. So we can say x equals 5 is a minima, the minimum point. Okay, let's find the next one, another example. Let's find g prime of x. That's going to be x cubed minus 2. Then let's find g double prime of x is equal to 3x squared. Okay, so now let's find any points of 0 here. So 0 here. So let's let that equal to 0. So x cubed minus 2 is equal to 0. X cubed is equal to positive 2. X is equal to the third root of 2. I do not know what that is. The third root of 2. It's 1.26. So now, that's the only point that we have. Let's substitute that to determine its nature. So let's go f double prime of 3, f double prime of 1.26. You can probably already tell that because this is positive and x squared is positive, then this here must be always concave up from the looks of it. But let's substitute it anyway. So that's 3 times 1.26 squared. So 3 times 1.26 squared. That's 4.76 approximately, which is greater than 0. So we can say f double prime of 1.26 is greater than 0. Greater than 0 means it's concave up. So this means that this here is a local minimum. So we can say x, sorry, not this point here, x equals 1.26 is a minimum. So I hope that gave you an insight in determining whether a point is a maximum or a minimum using the second derivative. Hope to see you in the next video. Best of luck.